Welcome to the Trellix Spotlight series. My name is Nick, and I will be your host. Today's session will focus on application and change control for Linux installation process and troubleshooting issues. This webinar will be recorded. If you prefer not to participate in the recorded session, please feel free to disconnect at this time. A link to today's recorded presentation will be emailed to all registered attendees. This webinar is a brief overview covering common use cases and scenarios regarding this topic. It is not intended to be all-encompassing. If assistance is needed, please contact Trellix technical support. If you have questions during the webinar, please type them in the Q&A window. This webinar may run longer or shorter based on your participation, and we recommend asking as many questions as you can to make the most of this series. If the Q&A window is not displayed, click the tab at the bottom of your session window and click on the Q&A icon. We will answer the questions during the final section of this webinar. If you experience any audio issues during the webcast, please drop and attempt to reconnect. Our presenters today are Bhavani Shankar Sharma and Bharath T. Bhavani has worked at Trellix since 2019 with an overall experience of 8 years in endpoint security products of different vendors. He specializes in supporting Linux and MACC platforms and is currently providing support for all Mac and Linux endpoint products. Bharath has worked at Trellix since August of 2019 and has an overall experience of 9 years in enterprise support and endpoint security products. He is currently supporting Trellix endpoint products on Linux and Mac platforms. Ladies and gentlemen, Bhavani and Bharath.
Thank you, Nick. Hello, everyone. Thank you for joining today's session. My name is Bhavani Shankar. I have my colleague Bharath. So today we'll be discussing about MACC for Linux. The agenda will be product overview of application and change control for Linux, installation process, kernel compilation, understanding installation with SE Linux, common installation issues. So let's discuss about the overview on application and change control 6.4.x. The overview. Trellix application and change control blocks unauthorized executables on servers, corporate desktop, and fixed function devices. Application change control monitors and prevents changes to the file system. Now, application control uses the dynamic whitelisting to guarantee that only trusted applications runs on the server, devices, and desktop. With application control, you can prevent malicious, untrusted, or unwanted software from being executed, automatically identify trusted software and grant it authorization to run, block users from introducing software that poses a risk to your company. Now, with change control, it allows you to write protect and read protect critical files from unauthorized tampering. You can also define trusted programs to allow updates to protected files. A change is only allowed if it's applied according to the software policies. Now, with change control, you can detect, track, validate changes in real time, prevent changes using protection rules, enforce approved changes policies. Now, how application control works. Let me show you this in a diagram on how application control works. So now, as you can see in the diagram, the first step, a user or application try to execute a file where application control and our Trellix agent is installed. Then solid core agent and Trellix agent are installed on a managed endpoint when a user or an application try to execute a file. Then the agent, Trellix agent, registers the attempt and sends that event to EPO. And then solid core agent checks if the executable is added to the inventory as whitelisted. If the executable is whitelisted, then the file is allowed to run, or else it will be denied. Now let's check how change control works in the managed environment. Let me show you this also in the example of a diagram. So the first, a system user tries to change a file or a managed system where change control and Trellix agent are installed. The change control software then recognizes the attempt change and uses the Trellix agent to send a change control event to McAfee EPO. Change control then analyzes the rules and policy enforced on the endpoint and allows or blocks the changes. Now, note the administrator manages these rules and policies through McAfee EPO. The read protection or the write protection is enforced and the user change attempt is approved or denied. The change control database log, the file attempt, and local user informations in the change control database. Now, let's check how the application and change control installation process works. So the first, the minimum, the basic requirement is to check for the OS compatibility using the KB article KB 87944. Let's compare if the OS is supported, we'll decide the installation type. If it's not supported, we'll raise the product enhancement request described in KB 60021 or submit a support request with technical support. Now, let's OS is compatible. We'll decide which type of installation we're going to go through. Is it going to be an EPO deployable or is it going to be a standalone deployment? Now let's look at the supported platform KB for confirming the OS and kernel support. KB 87944 and KB 91985. These two KB article, you can look at the screenshot. On the left, it's a supported platform for application and change control, where it's going to show you the OS compatibility for Windows and Unix-based operating systems. On the right, you'll see Linux kernel Linux kernel support for application and change control. This KB will be updated when there is a new kernel support is added. So let's look at the system requirement again. The system requirement must meet specific hardware and software specification to install and use the software. Review the requirement before installing or upgrading the software. So what we need, the below components and the requirements are the processors, single, multiple, AMD Intel Pentium CPU, memory of 512 MB RAM, and the recommended will be 4 GB of RAM. The disk space is 80 MB free disk space for installation on system volume, write permission on partition where the solidifier is installed. According to the supported file system for the installation, ext2, ext3, ext4, REIS, ERFS, and XFS are supported for the installation, and supported file system for solidifications are listed below. For managed environment, we need Trellix EPO server and database are installed and configured. Trellix agent is installed on each endpoint where you want to install the software, and your Linux distribution should be supported using the KB 87944. Your database size should be adequate. See the KB 72753. And for unmanaged, your system kernel should be supported. Check the KB 91985. And your Linux distribution should be supported, KB 87944. Now, let's look at the installation process and the demonstration. EPO console, where I have manage all my endpoints. System tree, where I have 2 of my endpoints for the demonstration to show you in the demonstration. So now we need to decide which type of installation that we're going to need. Is it going to be installing it manually, locally on the endpoint, or using it through Trellix agent deployment task through the EPO console? So now when we install it the first time, so we need to follow this workflow. Install the solid core extension on EPO server, adding the license key, adding the solid core client packages to the master repository, installing the solid core clients on the endpoint, and then the verifying the installation. And the similar way, the upgrade installation workflow. Upgrading the solid core extension on the EPO server, adding solid core client packages to the master repository with the upgraded version, and upgrade the solid core client on the endpoint, and then finally verifying the upgrade. So let's look at the extensions where we can download. So in this EPU console, I have the software catalog here, or I can go to the menu and go to the software catalog to review all my available options. So I'll quickly search for the application control here. I get these versions 8.3, 8.2, 8, and 6.4. So as discussed, so for the Linux, it is 6.4 is compatible, the maximum version. But however, the extension can be selected from the 8.3. I've already checked in the extension in my master repository. As you can see, it is 8.3.5.8 is the checked in version. In a similar way, you need to check in the solid core client packages. I have checked in 3 different versions depending on my needs or the operating systems that I'm using. So I have checked in the version 6.4.22, 6.4.23, and 6.4.21 in 3 different branches. And then it comes for the license key. I can download the license key from here. It says license file for McAfee application change control. In a similar way, if you're using the app change control application, then do the same for the change control as well. Download the extensions, which is already done, and then the license file. Now let's look at the installation type. So here, this is my computer. As you can see, the OS. So first thing I'm going to verify is my OS is compatible before I install anything here. So as you can see, this is my PuTTY session of this Linux operating system. Let's compare the operating system type. So I'll use this etc OS hyphen. So I have Red Hat Enterprise Linux 8.1 with the kernel version 4.18.0-147.8.1.el8_1. This can be confirmed from operating system KB article as discussed in my previous slides. 91985 is the KB article, and I can confirm if my OS is supported over here. The same way the kernel is supported or not. As you can see, this is supported from 6.4.7.105. Let's go ahead and deploy the package to this endpoint. So there's a 2-way here. Either I can deploy this to this entire group. I can create a task and assign a task to this entire group to schedule, run the upgrade or the deployment at specific time. For this demonstration purpose, I'm going to use the another way to deploy called run client task now for an immediate deployment. So I'll select this. Since my packages are already checked in, it's going to show me here. So McAfee agent is the deployment product that I'm going to use to deploy the package. The task type will be product deployment. I'll create a new task here and select the operating system as a target platform and Linux. Uncheck the Windows. Select the product that I want to deploy. So here I'll be deploying the latest version, which is 6.4.23 for the Linux. And the action will be installed and the appropriate branch. And I'll select the run task now. That will show me the live status of the deployment. And the same way, we can confirm this here inside the CD temp. As you can see, there is an install log is getting created here when I deployed it. You can see. So I'll use the tailf command to see the live request on what exactly happening in the background. So you can see the Trellix Solidifier service started successfully and the packages are installed successfully, right? In the same way, and now I can check what is the status of my solid core application here. So the command for that is sadmin space status. This will show me that what is the current status of the solid core. Right now it is in the disabled state and it is EPO managed with the local CLI access as lockdown. Now this can be controlled from the EPO console. I can go back, I can select the endpoint, I can click agent, run client task now, select the solid core 8.3.5, which is based on the extension version that I've installed, and I can select the action type that I needed. Either I enable, either I put this in the observe mode, inventory mode, or enable the local CLI access to lock or recover, allow or restrict. So now let's look at the manual installation of endpoint. So the second type installation, I'll be using this RHEL 8.1.2. So let's confirm the OS. So this is again the same 8.1. And what is my kernel version is 4.18.0.147. And I can confirm this using the kernel supportability article, and it is supported. So I'll be using the latest version here to install our software. So I've already downloaded the package here inside the solid core folder. So this is the zip package that we downloaded it from the software catalog earlier. Either you can check in master repository. Also, you can download it locally on your endpoint. So I'll unzip this package first, called solid core 6423-185_LNX, which says Linux. So these are the packages that I get generally. And make it a little larger screen for better review. So once I extracted this package, I will be giving an execution permission for the install file. The install file named as mappkg_install.sh. This is the install file. And I'll execute this file to install our solid core application here. So I just executed that and it's loading right now. It might take a few minutes. Let me open a duplicate screen and see what's happening in the background if there's a lock getting created in the background. Well, it's just installed it. So let's look at this. So right now, as you can see in the bottom, it ran the install and successfully completed the installation. So let's look at the status of the solid core enabled or not. You can see it's right now disabled, EPO managed, and local CLI is recovered. The reason why it is recovered here because I ran a manual install. When I do it from the EPO install, it will be in the lockdown as we saw this in the previous session. This is the previous one. As you can see, it was the EPO deployed and the local CLI access was in the lockdown. So this is the only difference that you will see here. And the command to check our services are services service SES RVC. SES RVC is the solid core service. And you can check the status. It is active and running right now. Right, so this is all about the installation demonstration. All right, we saw the solid core installation in our last demonstration. Now we will move to the next topic in our agenda, application and change control. Build tool process for unsupported kernel. So before application and change control installation, we need to make sure that running kernel in the client is supported with application change control 6.x in order to avoid any functionality errors. If it's supported, then we'll proceed with the installation. And if it's not supported, then we'll run the build tool for unsupported kernel using the KB article KB89516. Now, if recompilation works, Trellix ACC gets installed. And if it doesn't, we'll submit a support request with Trellix support. So let's look at the demonstration on how this is going to work. So back to my EPO console, I have these two machines here for the build support tool. So let's look at the configuration on these machines. First, I'll verify the operating system. This is 8.6, which is supported, and with the kernel version of 4.18.0372.26.1 EL8_6. Let's verify if this tool is supported. As you can see, this is supported, but it is supported with the latest version of Solid Core 6.4.23. So prior to this kernel is not supported. It is supported from November the 8th. What I'll do is for showing you as a demonstration, I'll be using the older package, which is 6.4.22, in which this kernel is not supported. So I have this package here in the Solid Core folder. As you can see, I already have a package called 6422_205. So let's extract this file. Okay, let me give the permission for the execution. Right, and this is a tool that I'm currently giving the permission for, build_target.tool. So first, let me show you how the installation fails with the unsupported kernel. As you can see, I ran the installation. Let me open a duplicate screen just to show you up what it shows while installing the log. You can see the side by side. It's trying to install right now, but in result, as the kernel is not supported, this should be failing it. So we'll wait till it fails, and then we'll proceed running the build tool. So let me, in the meantime, this runs. Let me explain you what build tool does in the machine. So basically, it downloads the development tools to perform a kernel module compilation. It downloads kernel development packages and code source files for the current running kernel version. It also prepares the ACC drivers, which is application and control drivers, sources for recompilation. It rebuilds the ACC driver with support for the newer kernel. And then last, it creates an RPM or a Debian file, depending on the operating system, Ubuntu or Red Hat. It creates the file containing the newly compiled kernel module assets in it. And then we can use these files for redistributing to other endpoints. For the moment, the distribution of self-supported kernel module isn't automated. The resulting ACC folder, including the newly created kernel modules like RPM and def file, must be manually compressed and redistributed to the other corporate endpoints. At the corporate endpoint, the master installer script must be run to fulfill the installation. If the latest ACC version is installed and provides the self-support for a newly kernel, you must uninstall the current version. First, reinstall on top of the same version, which is not supported. We'll continue to regularly add the kernel support to provide built-in support for newly kernel releases. So let's see the current status, which says is failed and it suggests us to run the build target.sh to configure our system for rebuilding the kernel module. So let's go back to the original screen, clear the screen. And now I'll run the build tool, which I explained to you for the recompilation. Now, this tool is supposed to recompile my kernel modules and install the software in it. It's again going to take a few minutes. Let's open the duplicate screen, which we had it, and confirm what's happening. It'll take a few minutes. So as discussed, in this list, I should be having one more file get created, the RPM or Debian file for transferring this to the other endpoint, which I'll show you on my second machine. How are we going to work on that part? So building the tools might take a few minutes. Again, let me refresh what it is doing. It's downloading the development tool to perform the kernel module compilation. It is downloading the kernel development packages, code sources files for the current running kernel version. It's preparing the ACC driver source for the recompilation. It is also rebuilding the ACC driver with the support for the newer kernel. And it created an RPM deb file containing the newly compiled version. So as you can see, it creates this specific file. Right now, it is in the temp location. This is the file name. So let's verify that. So before I verify that, let me go ahead and first run the installation. So what we did first, we ran the installation, which resulted in the fail status because of the unsupported kernel. Then we ran the build tool to compiling the kernel. Now I'm going to run the installation file again to make sure our software gets installed. It is installing it now. As you can see, this is the file that it actually got created here. So package installed successfully, as in the original screen that we can see. It's executing the build verification test. The result is in now passed. Let's get the complete status, and then we'll check the status of the solid core. So sadmin status is the command. Let's clear the screen and then show you. So the command to check the status is sadmin space status. Now this will show you the Trellix solidifier status. It's in the disabled state. After the reboot, it should be enabled depending on the command that I send it from the EPO as in the previous screen. Okay, so now let's look at the information that we have here in the solid core folder. So this is the file that got created here. Now I'll copy an entire thing in another target machine in order to uh, use it on the another machine, which is 8603 that I have here. So let me create a directory here to move these files. Let me keep a simple name, solid core build. I'll move these files, which I kept it somewhere here. Right. Copy these, move it into this temp solid core build folder. Might take a few minutes for me to copy it. Right, so files are copied. Let me go to the another machine, the target machine, minimize the other one and close the screens. Okay, so this is the machine, the another target machine, which is having the same kernel version. As we can see, it is unsupported, and I have the version, which is again 6422, which is unsupported for this. Solid core build. I have all my files here. So here, I'll simply use the execution permission for installation file. And I'm going to run the installation file here right now. So now this should install the solid core without running the build tool. So let's look at the duplicate screen if there's a log got created for me. So as we can see, cd/tmp ls. So there is a log file got created here. So tail-f solid core s3 install.log. You can see it's updating and installing. Package installed successfully here. Logs are created. And the service is also started successfully. And in the previous screen, as you can see, it's successfully passed. Let's review the status. Now, as you can see on the second machine, on the target machine, where we did not run the build tool with the unsupported kernel on the same 6422 version, we installed solid core, and right now it's in the disabled state. Now these can be updated here in the MACC EPU as well. There you go. This is again C603 /opt MACC agent bin cmd agent -p. This is I'm doing the wake-up agent call for endpoint to communicate with the EPU. These are my machines. You can see solid core is installed and 6422 version with the older version. And later, if I want to perform the EPU deployment, again, the same EPU upgrade procedure that we need to follow, running client task now. So this is all about the demonstration on running the build tool for unsupported kernel. Now, I'll hand over this to my colleague Bharath for proceeding with the other topics in listed agenda. Thank you.
Thanks, Bhavani. Hello all, thanks for joining the session. Today I'm going to speak about application and change control installation on a Linux enabled machine and common issue with application and change control. Let's begin with application and change control installation with Linux. First, what is Linux? Linux is nothing but security enhanced Linux. It is a security architecture for Linux system that allows administrator to have more control over who can access the system. Linux is part of the Linux security kernel that acts as a protective agent on servers. Linux only grants access if the administrator writes a specific policy to do so. There are three different modes of Linux: enforcing, permissive, and disabled. What is enforcing? When Linux running in enforcing mode, it enforces the Linux policy and denies access based on Linux policy. In Red Hat Enterprise Linux, enforcing mode is enabled by default. Now, what is permissive mode? Permissive mode is the most commonly used mode in Linux. SC Linux enabled but does not enforce the security policies. This means that actions will be allowed, however, it logs in the audit log for the system's admin's actions. Disable mode. In this mode, SC Linux turned off and the security policy do not protect the server. Now, application and change control can be installed on all three modules without any issues. Now, let's see installing application and change control when enforcing mode enabled on SC Linux. In this mode, as soon as you install application and change control, application services might not get started as SC Linux security policy denies access to load our application modules properly. So in order to overcome that, we need to allow them by running below commands using SC manage utility. Run the following commands, which is highlighted there. So what is SC manage? SC manage is a security Linux policy management tool. It used to configure certain elements of SC Linux policy without modification or recompilation. Now let us see the installation of application and change control when permissive mode enabled. Application and change control also supports SC Linux in permissive mode. In this mode, the SC Linux policy isn't loaded and access is denied to load any application. Before we proceed to install application change control, we should be aware of the steps. How do we change the SC Linux mode from enforcing to permissive? The steps are as below. First, edit the SC Linux configuration file from the path etc SC Linux. Then set SC Linux equals to permissive. At last, we need to reboot the system for the changes to get effect. Reboot is mandatory. Without that, change of mode will not happen. Note SC Linux supported starting from RHCL 7. Here is the reference KB 91660 that explains about application change control with SC Linux enabled on all modules. With that, let us move on to the quick demo. First, let us see how do we install application and change control on enforcing mode enabled. First, let me show you the SC Linux status with SC status command. Here you can see SC Linux mode is set to enforcing. So here I have already downloaded and copied application and change control latest version standalone installer package. First, let us unzip that. Unzip is successful. Let's run the installer. That is mappkg underscore install.sh is the install script. See, let me run that. The installation is happening. Here you can see the message package installed successfully. Yeah, now let's verify that with some sadmin command, whether it is successfully installed or not. Unfortunately, you can see the error failed to connect to the Trellix solidifier service. Service is not running. Let's run one more command to verify that. Same message. This is expected due to SC Linux security policy not allowed to load application and change control module in enforcing mode. So in order to overcome that, we need to run certain commands as explained earlier. Before that, let's verify the logs. What is exactly written over there? Yeah, we are getting the information. Here we can see the message is very clear. Failed to load KLM. That is our kernel module is not able to load it properly. So this is due to the reason that SC Linux blocking it. Our driver is unable to load it. So let's go back and see how do we overcome that. So like I explained earlier, we have certain SC manage command. If we run that, we'll be able to overcome this. Now let us run this. This will take a few seconds to get that passed. So after that, we have one more command to run. That is restore com. Yeah, this is successfully done. So let me proceed with the next command. Yeah, sorry, I missed on here. Yeah, this is done. So now let's verify whether our service is able to load properly with sfn command. Yeah, yeah, here you can see the service is showing the response properly. The expected output is coming. So let's verify with the more command status. Yeah, this is also going through properly. So now let's check the logs again to see what has changed now or what is the reason here. Here you can see the logs. It shows that it's able to successfully load the kernel modules and the driver of application and change control is loaded properly. That is SCDRP. So now it's successfully able to install properly after running the commands and giving the exception to the application and change control on the enforcing mode. So let's move on to the second part of the demo with that. That is installing application and change control in SC Linux permissive mode. First, let me show you the status of SC Linux. It's set to enforcing. Now let me demonstrate how to change SC Linux mode from enforcing to permissive mode. First of all, we have to edit VA editor to edit the config file from the path. etc SELinux, and then the config file. So this is the config file looks like. So let me insert to make any modification. Here you can see the SELinux is set to enforcing. I'm going to changing that to permissive. That is done now. Now press escape and type WQ exclamation to write and quit. Now let me show you the SELinux status again. This is not completely changed. In order to do that, like I have told before, we need to reboot the machine so that the changes will get effect and the mode will change completely. I'm rebooting the machine now. So this will take a few moments to come back. So in the interest of time, I have another machine which is already set to permissive mode. And we can continue with the demo there. I mean the installation. You can see it is set to permissive mode. So I already have a solid core standalone installer package here. So let me proceed with installation. First I'm unzipping the package. Yeah, here it is already extracted. So let me run the installer here. Installation is going through. It will complete in a moment. Yeah, here you can see the message package installed successfully and we are ready to go. So now let me run the command to check the status of solid core. It shows the details properly. Let me run one more command. And that is also successful. The version is showing properly. So it's all set. So now you can see there is no problem with permissive mode. So since there is no restriction, you can straight away go and install the solid core application and change control. That's all with the demo. Now let's move on to the final part of today's agenda. Here we are going to discuss about few of the common issues with application and change control. First, application and change control installation failure due to secure boot. The secure boot feature is not supported with application and change control software, and that can cause the application installation or functionality to fail. First, let's quickly see what is secure boot. Secure boot is a protocol that enables a safe and trusted path during the Linux boot process. It ensures that only trusted software can be executed on your system by verifying the digital signature of any executable files. Why secure boot is not supported with application and change control? When secure boot is enabled and configured on any Linux machine, then it only allows software or firmware which is signed with approved keys to execute. And whenever you install or upgrade different version of application and change control, then kernel needs to be signed again with secure boot. To verify whether secure boot enabled or not in the Linux machine, we can find it in two different ways. One, in the mockutil command, that is mockutil space -sb-state with sudo or root permission that will show you the exact status like you see it in the presentation. Another way is to grab the secure boot statement from dmessage log by running command dmessage space pipe space grab space -a space secure boot enabled. That will show you the status message like you see it here. From the installation log of application and change control, you will be able to see scSREC.service failed because the control process exited with error code. And the final error says failed to start Trellix solidifier. Here is the reference KB 94493 which points out secure boot is not supported. Next that we are going to see here is installation issue on XFS file system. Application and change control installation fails as XFS file system not supported. In the installation log, you can find installation failure reason as error processing archive solidifier kmod version.deb. File system XFS is not supported only as file system of installation directory. This issue is seen in Debian-based OS prior to application and change control version 6.4.22, and this issue is fixed at version 6.4.22 onwards. Here is the reference link of application and change control release notes. Last issue that we are going to see here is performance issue when installing application and change control on RDD enabled Linux machine. Here is a quick brief about what is RDD. It is the user space component to the Linux auditing system. It is responsible for writing audit records to the disk where it is configured. The RDD daemon is responsible for writing a log records to disk. RDD is configurable to allow control over what information is written to the logs. Why RDD causes issue with application and change control is when both application change control and RDD installed together on the same Linux operating system, they are using the same hooking mechanism for the file system operations. They both inject over the same file system. That configuration is not compatible with application change control. When we install both application and change control and RDD together, mostly it causes performance issues like CLI command to hung or the server goes to hung state. So that is the reason RDD is not compatible with application and change control. And here is the KB 92460 that explains about the same. Hope the information shared by us today will be helpful. Thanks for joining the session.
Thanks, Bhavani and Bharath. As a reminder for everyone, Trellix Education Services offers exceptional training to go along with our award-winning products. If you would like to learn more, please visit the website listed on the screen to see all of our offerings. Now let's get our Q&A session started. I see we have several questions, but it's not too late to add your question. Please type it in the Q&A window to submit. Additionally, take a moment to fill out the survey. Your feedback and suggestions are always appreciated.
What is the expected timeline to support the new kernel in Solid Core?
Well, that's
Let me answer
basically for 60 days. Sure, Bharath, go ahead, please.
Yeah, sorry for the interruption. In general, application change control follows standard release channel for kernel support and can take up to 60 days to support the new kernels. However, in the meantime, you can use kernel compatibility checker on the newer kernels to allow them to be automatically supported on 0 days, mostly 80 to 90% of the times, provided the kernel is supported by OS vendor itself. If not, in case of any special scenarios, you can always bring it to us so we can consider engaging our developing team and do the needful accordingly. And there is a reference KB 89516 that highlights about the kernel supportability guidelines.
Got it. Okay, perfect. Thank you for that. What is observe mode? Excuse me.
Yes, I'm sorry. I'll take this question. And the observe mode. In the observe mode, application control records the execution, installation, and uninstallation activity for the managed endpoint. And in the observe mode, a file is allowed to execute unless it is banned by a specific rule. All the observations generated on the endpoint are sent to the MACC EPO server after agent-server communication interval. So basically, when an endpoint is in observe mode, no application control events are generated for the event. So there are options to put this endpoint in the observe mode and exit mode through the manually or through the EPO. That's the answer.
Got it. Okay, perfect. Thank you for that. Is observe mode available on Linux OS?
Yes. You can either do it manually or through the EPO server.
Got it. Okay, perfect. Thank you for that. Is there any plan to include secure boot for supportability in the future?
Yeah, including secure boot with application and change control product requires major design change. However, considering the fact that secure boot is widely used in Linux machines, our engineering team working on it. So it will be released in the future release of application and change control, but we do not have any definite time frame to it. Yeah, that's it.
Got it. Okay, perfect. Thank you for that. It looks like that's all the time we have for today's session. I want to thank everyone for joining today's webinar, and a big thank you to our speakers. As a reminder, a link to today's recorded presentation will be emailed to all participants. This concludes today's webinar. Stay safe, everyone.
Thank you.
Thank you.
Thank you.